So today we will discuss some important topics of module 5. Module 5, that is real gases. Real gases or real gas mixtures. Okay, these are the two topics. So in these topics, I will be discussing you with, let me take the different color chalk piece. Okay, here the topics, first topics is compressibility factor. First topic I am going to discuss today is compressibility factor. Okay, and in the previous class we also discussed the difference between ideal gas and real gas. This is very important to understand all these topics, today topics. And second one is law of corresponding states. Law of corresponding states. And third one is numerical. Numerical. Okay. So numericals of real gas and ideal gas. So to understand these three topics, first what we do is you'll understand the difference between real gas and ideal gas. Okay. And you have discussed in the previous class. First, I will write the equation of ideal gas. Ideal gas, it is also called perfect gas. Perfect gas. So PV is equal to mRT. This is ideal gas equation. Or some books they can write N R bar T, where R stands for gas constant and R bar is universal gas constant, that is 8314. Okay, so what is real gas is real gas. What is the definition of real gas? The real gases does not obey the gas laws, or we can say the real gases are those gases which have intermolecular force of attraction between the molecules. Okay, ideal gas is no intermolecular force of attraction, and ideal gas obeys all gas laws. It obeys all gas laws, but real gas do not obey gas laws. Okay, this is one point, or else you can write intermolecular force of attraction will be considered. It will be there. Intermolecular force of attraction between the two molecules is considered in real gases. Okay. In ideal gases, we'll assume it is the force of attraction between the two molecules, or intermolecular force of attraction is 0. That is one point. So there are different types of real gases equations are there. So, but for your syllabus, for your curriculum, there is one equation I will write here. P plus, I will write on the board, P plus A by V square into V minus B is equal to mRT. Sorry, mRT. So this is the equation. What is a real gas equation? Real gas is a Vander Waals equation. So Vander Waals equation is P plus A by V square into V minus B is equal to mRT. Okay, dear students, same equation in some textbooks, they will write P plus A by V square into, okay, into V minus B into V minus B is equal to R bar T. R bar T. This is also an ideal gas equation, real gas equation. But in this case, what is the difference between these two equations is, here we will be considering molar volume. What is this V bar? V bar is molar volume. So I will be using this equation because it is very easy compared to this. Here it does not require mass and as well as gas constant. And here I am writing in terms of R bar because R bar value is constant. We know it 8.314. So this use of this equation is easy. So I will be using this equation. You can ask a question, sir, how this equation is derived using this equation? And it is very easy, my dear students. R is equal to what? R bar divided by molecular weight. So in place of R bar, here, if I write like this, what will be the equation? I will write R bar divided by M into T. So M by M is number of moles. So that number of moles is divided here. So that is very easy concept. Don't get confused. Okay. So both are same. Both are same. Either you can use the first equation or use the second equation. So it doesn't make any difference. Okay. But when you are writing the equation, second equation, keep in mind on the right hand side, it should be R bar T. On the left hand side, here volume, it is not volume, it is molar volume. Okay. So these are the 2 points you remember. And I will be using these two equations. PV is equal to MRT in the numericals and as well as this real gas equation. Okay, first point, what is the point we are going to discuss is compressibility factor. It is important for exam point of view. Compressibility factor will be represented with symbol Z. Compressibility factor will be represented with symbol Z. And what is this Z says is the compressibility factor Z, it will define or it will state the conversion of ideal gas to real gas. So what is the meaning of this? Means at what value of Z it is in ideal gas. Okay, for example, if the value of Z is equal to 1, then we will call it as ideal gas. If the value of Z is not equal to 1, then you call it as real gas. Real gas. Now the question is, sir, where this Z is available? This Z is available in ideal gas equation. Again, so we will write PV is equal to Z R T. PV is equal to Z R T. What Z is called as compressibility factor. Okay. So if write the equation Z is equal to PV divided by RT. So if the value of Z, if you are getting equal to 0, then you decide this is ideal gas. Okay. For example, some gas, I will give pressure, I will give volume, I will give R, and I will give T. Substitute all these 4 values in this equation. Then if you got equal to 0, sorry, it is not 0, it is equal to 1. If it is got equal to 1 exactly, then I'd assume it is ideal gas. If the value of Z is not equal to 1, then it is real gas. So in simple word, what is Z is? Z is a compressibility factor. It is a measure of deviation of real gas to ideal gas. Deviation of real gas from ideal gas. I will write here Z is a measure of deviation. Deviation means changing. Deviation of the real gas from ideal gas. You can say easily. Easiಯಾಗಿ ಹೇಳ್ಬೋದು. ಏನು Z ಅಂದ್ರೆ compressibility factor ಏನು ಅಂದ್ರೆ, so at what value of Z the ideal gas is converted into real gas. Okay, so that is the value of Z. Okay, you will be solving the numericals and calculating compressibility factor. Okay, so next topic is law of corresponding states. Very easy topic. It is a definition. It will be asked for 3 marks or 2 marks in the exam. It is very easy topics. So law of corresponding states is also called as, keep in mind, this will be also called as limiting pressures. what you call corresponding or reduced pressures or reduced properties. Keep in mind, one more word is define law of corresponding states. It is also called as define reduced properties. Both are same. Reduced properties under one, law of corresponding states are same. Both are same. So what is this reduced properties? My dear students, how many properties we are considered usually in thermodynamics? Pressure, volume, and temperature. Always, most of the cases, we will deal with these three pressures. So reduced properties you have to define with respect to pressure, with respect to volume, and with respect to temperature. So as the name indicates, it is reduced. So reduced pressure, I will write PR. Sorry. So reduced volume, I will write VR. Reduced temperature, I will write TR. So reduced pressure is defined as the ratio of pressure of the gas divided by critical pressure of that gas. Okay, critical pressure, this value will be available from the thermodynamic data handbook. Critical pressure, critical point, already we discussed in the previous classes. Critical point, triple point, etc. So the property measured at critical point is called critical pressure. So similarly, what is reduced pressure is? Reduced pressure is defined as ratio of pressure of the gas divided by critical pressure of the gas. So my dear students, now I will write the definition of reduced volume. Now you tell me, what is reduced volume? Reduced volume is defined as ratio of volume of the gas divided by critical volume. Very easy. Okay. Similarly, reduced temperature is what? Temperature of the gas divided by critical temperature. Okay. So these three equations you need to write in the exam. How the question will be asked in the semester exams or in the internal papers? Define law of corresponding states, or define or state reduced properties. You should say there are three reduced properties: reduced pressure, reduced volume, reduced temperature. Reduced pressure is pressure of the gas divided by critical pressure. Reduced volume is defined as volume of the gas divided by critical volume. Similarly for temperature. So these two are important topic you need to remember. Okay. So now I will go to the third topic is numericals. Simple numericals. Again, it will be asked in the exam. So first numerical is this one. Okay. Determine. Okay, all of you read the statement. If you have a calculator, please open the calculator. Be ready with calculator. We need some values. Determine specific volume of carbon dioxide. Specific volume means what? Specific volume. V. Always specific volume will be represented with symbol V. Okay. What type of gas? Carbon dioxide. 200 degrees Celsius temperature. So temperature is 200 degrees Celsius. Converted to Kelvin. So here it is 473 Kelvin. And 60 bar pressure. So P is equal to 60 bar. So bar we convert into Pascal. So we need to multiply with 10 to the power of 5. Okay. 1 bar pressure is equal to 10 to the power of 5 Newton per meter square, or 10 to the power of 5 Pascal. Both are same. By the use of perfect gas equation, first I need to find out the specific volume using ideal gas equation. First, find what is as find or determine specific volume using ideal gas. Using ideal gas. Second, same again you have to find the specific volume using Vander Waals equation of constant. That is real gas. That now we have discussed Vander Waals constant. Vander Waals equation. So first what I do is I will solve specific volume using ideal gas equation. Okay. You take this is step number 1. And step number 2. Step number 2. What is ideal gas equation, my dear students? PV is equal to mRT. First you write the formula. PV is equal to mRT. Here P is pressure, V is volume, M is mass, R is gas constant. Gas constant is not equal to universal gas constant. Both are different. Keep in mind, my dear students. This value of R is equal to R bar divided by molecular weight. So many of the students, they do mistakes in exam is they consider both are same. Both are not same. And T is temperature. But in the question paper, he has asked specific volume. He has not asked the volume. He has asked specific volume. So specific volume is always volume divided by mass. Volume divided by mass is specific volume. So is equal to RT. Okay. So now this equation I will write as P specific volume is equal to RT. But in the given data, gas constant is not given. Has he given gas constant? R is not given here. R value is not given. But we need R value. So what we need to do? Simple. R is equal to R bar divided by M. How much is the value of R bar? 8.314 into 10 to the power of 3 divided by how much is the molecular weight of gas? Which gas he has given in the numerical? Go to first given statement. Which gas it is? Carbon dioxide. So molecular weight of carbon dioxide is 44. If you don't remember the molecular weight, in thermodynamics data handbook, go to page number 61. Already we have solved many numericals in the previous module. So I think you know it, how to take the molecular weight of carbon dioxide. Go to page number 61, find out the molecular weight and substitute in the given step 44 and tell me the value of R. I will write this R value, I will get as some value. That value I will directly write here. So specific volume is equal to R value. This R value I will write 8.314. If you have calculator, you simplify. Okay, this value I have written here. Now I will write the temperature. Temperature is how much he has given in the numerical? Most probably it is 473. 200 is given. 273 we have converted to Kelvin. So it is 473. So 473. And on the left hand side, there is pressure. That pressure value I have to take in the denominator. This value I have to take in the denominator. So how much is the pressure? 60 bar. So 60 into 10 to the power of 5. So if you simplify this equation, so I will get the volume is 0.014. 0.014. If you take one more digit, 8 I will get. So meter cube per kg is specific volume. Specific volume. So if you have calculator, you cross check this value. Okay. Next is, so using ideal gas equation, I need to solve same specific volume using ideal gas equation. Okay. So what is ideal gas equation? Step number 3. What is ideal gas equation? That is Vander Waals equation. P plus A by B square into V minus B is equal to R bar T. This is one type of ideal gas equation. This is Vander Waals equation. What is the name of this equation? Vander Waals equation. Okay. Here you need to remember one important parameter is V bar is molar volume. Molar volume. Okay. R bar is gas constant. That is universal gas constant. 8.314 into 10 to the power of 3. T is temperature. My dear students, P is given in the numerical. And he has asked to calculate specific volume. That we will calculate. Okay. That is unknown. But we don't know A value and B value also. how to take the constant of A and B. What are these A and B? A is Vander Waals constant. A and B both are Vander Waals equations of constant or constants of Vander Waals equation. So here, these two A and B value, again you will get in thermodynamic data handbook. Okay, if you have thermodynamic data handbook, you open the thermodynamic data handbook. I will tell you the page number. Page number is, let me open and I will tell you where it is exactly located. All of you open thermodynamic data handbook, which already you have taken. Okay, so go to page number 59, my dear students. Go to page number 59. On page number 59, in the thermodynamic data handbook, so they have given different types of gases and as well as A and Y value. Okay, all values are available. So for example, the given gas is carbon dioxide for us. Let me open the new page. Sorry. Okay. Let me open a new page so that I can write easily. So all of you open page number 59 and note down the value of A and B. So for carbon dioxide, the value of A, I am going to write from page number 59. A is equal to, for carbon dioxide, it is 365.6. I hope you will find the same value in the book. And unit is also given in the book. Okay. Next, one more B value, B constant value required. B is equal to 0.0428. So substitute A value as this much, B value as this much. Pressure P is equal to, how much he has given? 60 bar, I think. Yes, correct. 60 bar, 60 into 10 to the power of 60 into 10 to the power of 5. This is B value. A value, B value, and P value. Temperature is 473. If you substitute in the above equation and calculate V bar, please try to calculate the value of V bar. Let me open calculator. Here, specific volume is V. V is equal to molar volume multiplied by N. But my dear students, I don't know value of N. What is N? Mass divided by molecular weight. Okay. So if this is the case, if you don't know the mass, so what we need to do is specific volume is equal to molar volume divided by molecular weight. You can also do like this. Molar volume divided by molecular weight. So molar volume is how much he has given? 0.612 divided by 44. And to calculate, let me know how much value will get. I have a calculator. 0.612 divided by 44 is equal to 0.0139. This is meter cube per kg. Okay, so this equation I will be using because he has not given mass. Mass is, we cannot assume it is 1 kg. If you assume 1 kg, again 1 by m. That also you can do. So this is simple formula, simple equations. Okay. So let me go back to the first screen. So what we have written and we will discuss. Okay. Determine specific volume of carbon dioxide. So instead of taking the same numerical, can we take one more numerical? Because anyhow, you have understood this numerical. Let me go to the new numerical. Similar kind of, similar, not changes. Okay. Try to finish in another 5 minutes. So determine pressure exerted by carbon dioxide. What he has asked here, it is pressure he is asking, not specific volume. In the previous numerical, he asked specific volume, V. In a container, what is a gas? Gas is same. Gas is carbon dioxide. Write down, all of you write. Gas is carbon dioxide in a container of 1.5 meter cube. Container volume 1.5 meter cube. Volume is given. Capacity when it contains 5 kg of mass. So here in this numerical, he has given 5 kg. So no issues. 27 degrees Celsius temperature. Simple, 27 degrees Celsius. You convert by adding 273 into Kelvin. So how much you will get? It is 273 you add and convert into Kelvin. So 300 Kelvin is a temperature. And using ideal gas. Again, you calculate pressure using ideal gas equation and as well as calculate pressure using Vander Waals equation. What is the second? He has used Vander Waals equation. Okay. So write down the equation now. So what we need to find out? Using pressure gas, using pressure. Keep in mind, you have to find out P value. So step number 2, what we need to do? PV is equal to MRT. MRT. This is the equation. Okay. So we don't know P, right? P as it is. And remaining all terms you send on the right hand side and simplify. You check how much is the value of P. Simple equation. So using this equation, P is equal to MRT by V. Okay. So M is how much? 5 kg. And dear students, we don't know R. But to calculate R, we know the formula R bar divided by M. So I will write here R bar divided by M. Later I will substitute. Temperature is 300 divided by how much is the volume he has given in the numerical? Volume is 1.5 meter cube. 1.5. So again, I need to substitute R bar value 5 into 8314. This is the constant of R bar. Or you can take 8.314 into 10 to the power of 3. 10 power of 3 into 300 divided by 1.5. Okay. And what is the molecular weight? M value. I have to take M value here. M value is 44. Carbon dioxide molecular weight is 44. So you simplify and tell me the value of pressure. Pressure, okay, let me do in the calculator. 5 into 8.314 into 300 into 1.5 into 4. So I will get the value of P is 188.96. Hope all students are getting the same answers. Kilopascal. I'm getting 188.96 kilopascal. So this is using ideal gas equation. Yeah, use ideal gas equation or perfect gas. Ideal or perfect gas equation. Now I need to use Vander Waals equation and find the value of pressure. Whether I will get the same equation or not, we need to check. Step number 3. So in step number 3, what is Vander Waals equation? Vander Waals equation is P plus A by molar volume square into molar volume minus B is equal to R bar T. Okay. Now here unknown is pressure. And you need to do some trial and error. Okay. If you have calculator, you can do directly. So R bar T divided by V by minus B. This is a value on the right hand side. Minus this term I will take on the right hand side. Okay. This term is minus A by V bar square. Now check which data is given, which data is not given. Okay. R bar is not given, but we know standard value. It is 8314. T is how much? 300. And dear students, constant A value and constant B value, you have to take from thermodynamic data handbook. Okay. Because carbon, you cannot remember the constants of all gas constants. So sometimes it will be given in the question paper directly, or else you need to ask a permission to refer thermodynamic data handbook. They will issue in the exam. So A and value and B value. So A value already I have taken in the previous numerical because it was carbon dioxide only. A value is and B value both. A value 364.3 I think. B value 0.0427. I think we have seen the previous 0.0427. Okay, substitute all the value and calculate pressure. And keep in mind, this is molar volume. I cannot substitute directly as 1.5. So V bar is equal to V divided by N. Okay, V is how much he has given? 1.5. How much is the number of moles? Again, we don't know number of moles. He has not given in the statement. So to calculate number of moles, what is the formula? N is equal to mass divided by molecular weight. Mass is 5 kg. Molecular weight is 44. So 5 divided by 44, you do it, you will get 0.11 something. I will write here 0.1136. So this value you substitute here. So then you can calculate V bar is equal to 1.5. So value of V bar, that is molar volume, you will get 13.2. So this 13.2 stood in equation number 1. In the equation number 1, you substitute the value. Take this as equation number 1. This is equation number 1. So in this equation, if you substitute V bar, you will get the value of pressure P as, so let me substitute all the value. P is equal to, how much is the value? 834. Temperature is 300 divided by V bar is 13.2 minus B is 0.0427 minus A value 364.3 divided by, and dear students, it is V bar square, molar volume square it is, so do not forget. So many students, they do the mistakes in taking the value of V bar in the right hand side. Here 13.2 whole square we need to do. So final value of pressure, again you will get the same as 180 range 183.57, okay, kilopascal. So this is the value of pressure of the gas using Vander Waals equation. And one more we said, that is the pressure of the gas using ideal gas equation. How much you got? It is 188. This is using ideal gas equation. Okay, these are the numericals of ideal and real gases. Okay, so thank you. So in the next class, we will be discussing with some more numericals of real gas mixtures. Okay, so thank you so much for attending this class. So take care. Bye bye.